Hi again. In this lesson we get to compare 3 or more means. I guess you could do 2, but we'll do 3 or more in what's called an ANOVA, analysis of variance. Okay, so this is a kind of an acronym. The AN comes from analysis, the O comes from of, and the VA comes from variance. Okay, so, and I'll explain why we switched from means to variance all of a sudden. Why are we talking about variance? Okay, so as we've done before, we've compared multiple counts or proportions, and remember we used the chi-squared test when we did that, and those were tests of goodness of fit, homogeneity, and independence. Now we're going to use ANOVA to compare multiple means, okay? And we get to learn a new distribution, so this is going to be called the F distribution, okay? So we're going to learn all about that. So let's look at an example that we'll use in this lesson. So a study examined the relationship between playing football and concussions on hippocampus volume in the brain. Okay, the study included 3 groups with n equals 25 in each group. The data for the study are shown in a spreadsheet, as usual, and they give the brain volume in microliters, okay, which uses the mu, which is also sometimes an abbreviation for micro, or a symbol for microliters, okay, so group 1 were healthy control subjects who had never played football, okay. Group 2 were football players, and they had no history of concussions. Group 3 were football players with a history of concussions. Okay, so this is an interesting study. Now, first of all, is this an observational study or an experiment? What do you think? Okay, if you said observational, you're right, because we cannot give someone a concussion, right? We could not do an experiment where we said get a concussion. Now we could, observe players over the course of a season, right, or more, and identify football players, and then at the end we would know who had concussions and who did not. But it's still observational, right? Because we can't give people a concussion. So let's just make a note of that. Observational study, not an experiment. Yeah, I don't think I need to say any more than that. Okay, perfect, but good thing just to note the difference. Okay, do you think there might be a difference in brain size between the 3 groups? So let's write out our hypotheses. You can see what you think, and we'll see what the data show. So let's write out our null. This time we are going to use all 3 groups. So we'll write it out, mu1. It's kind of nice we have group 1, 2, 3, because it would be a lot to try to summarize this with just one letter. So we're going to use mu1 equals mu2 equals mu3. Now we could use the subtraction way as well, mu1, but it gets a little trickier when you have 3. So I guess we need to do it this way instead. So we need to use the equal notation. So the null is no difference. And the claim, the way we'll write this out is in words. We'll say at least one of the means is different. Okay, so it's very similar to what we did for proportions, but now we're doing means. Okay, great. So we are going to go ahead and enter our data into Stapplet, 1 quantitative multiple groups. We're going to label the groups and make sure we have the labeling the groups and the units with the variable name. And then we're going to play around with this to just kind of explore, and then we'll go into the details of the test in the next video. So let's get our data. So here's our data sheet, and we can see we have the variable at the top, hippocampus volume in microliters. We have our control, we have our football no concussion, and football concussion group. Okay, and we have 25 in each group. Okay, so let's go ahead and enter all this in. Let me copy my variable name. Okay, and we were using this one in the last lesson. I'm just going to hit reset everything. Guess it didn't do that one. Oh, shoot. I copied instead of pasting, so I gotta recopy it. There we go. Okay, and we're doing raw data. We will have to add a group so that we have 3. And I'm going to go ahead and copy each of the group names, or you could type it if you felt like that was faster. Okay. And then copy each set of data. Make sure you get them in the right order. Okay, here's the third one. Okay, if we had 4 groups, we would add another one. There is also a minus, so if you accidentally add too many groups, you can put a minus here. I'm not sure what it does with a blank group, so but you could play around with that if you want to. Okay, begin analysis. So we do have all of our 3 histograms here. We also have, if we wanted to look at 3 box plots. Pretty cool, huh? Okay, so let me go back to the notes for a second before we go too much further. I've got the input screen, a screenshot of the input screen here. Okay, so we are using Stapplet 1 quantitative multiple group, and then be sure you put in the variable name, the group names, and the data. Okay, and you might need this add group or this minus group button. Okay, and then of course begin analysis. Okay, let's see what I want to do first. We're going to click on begin analysis and select the histograms first. Check whether these are nearly normal, then select box plot to compare the box plots side by side. Okay, so first we're going to just kind of play around and see if we think, you know, that's probably going to come up in the conditions, right? Because it has for every case with means. So let's go ahead and take a look at that now. Okay, interesting thing, the box plot in the concussion group does show 2 outliers, right? One is just barely past the, it's just barely an outlier, like the fence has to be in here because these are 2 data points, so it's just barely an outlier. Although the scale is probably, the scale is actually 500 microliters, so this one is a little more significant. And let's go back to the histograms. What do you think about nearly normal on these? The bottom 2 look fairly normal, slightly skewed. Let's look at our summary statistics. So we compare our mean and medians. It's hard with larger numbers, 7,300, 7,600, 65, 65. Yeah, so the middle one looks a little more symmetric. And then the third one, 57 and 57. So yeah, actually the bottom 2 aren't that bad. The top is a little more skewed, right? That one is 66 to 76, oh sorry, I looked at the wrong one, 73 to 76. Okay, so top one maybe not nearly normal. Doesn't look quite symmetric. That one definitely looks more skewed to the right. So interesting, huh? I would say proceed with caution. I want to do this example. So I'm going to say roughly nearly normal. There are 2 outliers and some skew. So I'm going to say proceed with caution for practice. Okay. Okay, now let me see what's on the next page. Okay, yeah, on the next page we're going to look a little more in detail at the box plots. So let me go back to the box plots here, graph type, box plot, and then also I'm going to switch my page on the notes. Okay. Okay, so we've got our box plots. What do you think about the means? So there's an interesting thing. We don't actually see the mean on the box plot, right? But it does give us a nice sense. We don't see it on the histogram either. This does give us a nice sense of like the spread and just the variation overall, right? Like, do you think these 3 groups look different? Okay, they kind of seem to. At least the control seems more different than the other 2, right? Like between the no concussion and concussion, I'm not sure how much difference there is. Concussion seems a little smaller. This is interesting because I didn't know which way it would go. Would it be larger or smaller, right? So it does seem like with concussions is maybe overall a little smaller than no concussions. I don't know if it's significant yet. And both of those seem smaller than the control group overall. So pretty interesting. So what we can do is kind of put where the means are. So the mean is 70. Let me go from the top down. 76. So I'm going to put just a little kind of X and circle where using the scale at the bottom, just real rough idea, but that's the mean right there, right? And then I'm going to do the same thing for the mean of the second group, 64, it's close to 6,500. So I'm going to put that right there. And the third group is 57, so below 6,000, just about right there. Okay, so those are the 3 means. So do those look significantly different to you? And yeah, it seems like they might be, right? So let's just write the means seem pretty different. Okay, so, but that's not a very scientific method, right? They seem pretty different. Also, difference not very specific. So let's just continue, but I just want to get an impression from the graphs as we explore this. Okay, and here is our summary statistics. So I guess I had my means right here the whole time. These are X bars, these are our S's, right? And these are our N's. So those are probably what we're going to use the most. Those are our 3 groups. And now I want to just play around with, we know we're going to use ANOVA, and because we have the beauty of technology, I want to just go ahead and hit this one-way ANOVA under perform inference. And I'm also going to include a follow-up analysis using a confidence level of 95%. And click on perform inference. Okay, since you have so much experience at this point, I want to just explore what this shows us, and then I'll go ahead and explain what everything means. Okay, and I have the screenshot of this on the notes as well. Okay, I'll write out what we just did. So inference procedure is one-way ANOVA, and then we checked this for 95%. Okay, and then we're getting this. And we're also getting this confidence interval output at the bottom. That's if you check the box. Okay, so let's just see, what do we notice from this? Well, we have a p-value. Might start all the way over here, right? So we have a p-value. It looks small, so it looks significant, right? Reject. P-value is small, we reject the null. So it looks like there is a difference. At least one mean is different. Okay, we still don't know if all three are different. Then we also have an F value. So this is our test statistic, our F statistic. Right, we would see a Z or a T there if it was a different type of test. Okay, now we also have some degrees of freedom, so you're more familiar, a little bit familiar with that already. Okay, interesting, we have several lines here. So we have group, error, and total. And notice when you add those, you get that. And then we have two things called sum of squares and mean square. Okay, so I will explain what all this means. But just I want you to just kind of look around for some patterns in the table here. You might notice this number looks almost exactly twice that number, and it is. And that's because the degrees of freedom are 2. So if you take this number and you divide by the degrees of freedom, you get that number. This one we'd have to test it, but it is true. Same pattern as in this table. So this one, if we also divide by degrees of freedom, we would get that. And then these two, if you add, just kind of, which makes sense with a total column, if you add them, you get that. Okay, so just some interesting things. We don't know exactly what's going on yet, but it seems like as long as the conditions are met, we're going to reject the null, right? Okay, and then take a look at these confidence intervals. What do you think that might show us? Group 1 to group 2. These are individual differences, right? So it's maybe not individual, is not the best word, but pairwise is a better word. They're pairs of the 3. So group 1 minus group 2, both positive. Group 1 minus group 3, both positive. Group 2 minus group 3, both positive. Interesting, right? 0 is not in any of those intervals. So it does look like, and this is a really nice, fast way to compare the pairs, because remember, if we reject the null, we still don't know which one is different, right? It could be just one of them, or it could be all 3. So it does look like the 3 means are significantly different. There's not in any of the intervals, so it looks like, from everything we know so far, looks like the 3 means are significantly different. Okay, let me make sure that's on the screen. Okay, Great. So I want to stop this video here and then we'll go into more details. I'll explain what's going on here so that you get a better sense of, first of all, why are we using variance? Why is it called ANOVA? And what do these sum of squares and mean squares have to do with anything? Okay, great. I'll see you in the next video.